Hello, this is my fourth assignment for computer graphics. This is the ray tracer. We have a few cool features. I like this dial bar because it allows us to change resolution and ray tracer depth. So if it's down here, it's at a very small depth of reflection, maybe 2 or 3, and then up here it's like 17 or something big like that. And obviously the resolution changes. And we can move around. It's a little slow with this level of detail. Actually not too slow, but if we turn it down it's quite fast. And it's still doing the same calculations, just on a smaller image. So we can kind of move the camera around where we like, and then say, okay, I want to have like this picture, and then we can kind of calculate it, and it's still real time. So let's just kind of explore for a minute. I restricted the camera movement a little bit. In terms of it can mostly just rotate around the axis. It was very hard getting the colors exactly right. I had to do some tricky math, and it's not really quite perfect. As you can see, the colors change as we go into a higher depth. Another thing that's happening is several lighting layers that are accumulated for every pixel. So that looks kind of trippy, as if you can see through it, but it's probably because there's so many reflections that it's hitting reflections, I guess. I don't think it's because you can see through it. I think it's an effect, but I think it's just from reflections. Refractions are not implemented. But there's still more cool shit. Shadows are hard to see because planes are not really implemented as such, but I might get there, but I might not. But you would probably see shadows very easily just from the reflections. As it such stands, you clearly see reflections into the darkness. It's just a little bit harder to see reflections with these spheres, but they are there. There's no refraction, but there is reflections, and there is multi-sampling. I multi-sample 3 times, and those multi-samples are also jittered a little bit, so that solves some of the issues. If you can get close to certain forms, they certainly do look pretty good. It's just a little bit hard to get close to something as it stands. There we go, so that looks pretty nice. Very simple, and obviously nicer. On the green sphere you can see reflections coming back. There's no way to indicate where the lights are, but there's about 6 lights in the scene, and I think that should be obvious. It's hard to see, but the code speaks for itself. Yes, there should be a few more things to say about this. I implemented it in such a way that creating geometries besides spheres should not be a problem, but when the going got tough, the code got a little bit icky, and I just didn't really have the wherewithal to implement much more than spheres. It's just because the code got so gross, hard to really describe. I don't know why it flickers, but it seems to work better under certain scaling. It might have to do with the weirdness of the colors. I have no idea, because like I said, the colors are just not, I don't know, it's a little bit spooky as to how it works, I guess is how I describe it. I followed basically what you'd expect to do, but it just took a lot of fiddling to get it to look exactly the way I wanted it to, and not too bright and not too dark. I'm pretty happy with it. And look, it's moving quite fast. Look, that's the highest depth, and it's chugging along. So there's only about, like, what, 10 spheres and 6 lights, but that's pretty decent, I would say. If I had a few more objects, it would look prettier, but all this video should assure you that it's acting as you might expect. So that, you can see there's a reflection and a shadow. It looks like we have a reflection and a shadow on that particular sphere, the pinkish one. Now, the objects are also animating. Every single one is moving towards the other ones. it's sort of a simulated gravity, but very slow and intentionally faster, so not every operation is done on every other operation. You'd have to see the code, but it's basically gravity, but a little bit slower. And then there's some that just move on their own clip, as far as I remember. The lights as well are moving, so it's supposed to be a ray tracer in the effect of a game engine style, where you can kind of just move all the spheres and lights around. It's doing it in the code. It's a little tricky to see, and definitely there is some issues with basically sharpness as to how sharp things are, if that makes sense. The things are, they could be smoother. Even though we're using multi-sampling, we're getting rid of some bad effects, but it does look really nice when you get really close to a sphere, which is a little bit tricky with my movement code. But let's just keep exploring for a little while longer. Not too much else to say. The game has a label that's associated with the drawing area, and that drawing area is basically touching a bit of objects in a separate class that were set up. It's called a world class, and that's where all the stuff is handled. There's a straight up material class, so that's why you can see there's different types of spheres. Some are shiny, some are differing amounts of ambient, specular, and diffuse lighting. So it's tricky to see like all those things working together, but it does look pretty nice. But let's try and find an example. So we see some I think there's diffuse lighting on these two darker spheres, if that makes sense. I think those lights that come through are diffuse, especially with the dropping off shininess factor, if that makes sense. So we also have shininess implemented. Yes. So just a lot of standard features. My main goal was pretty much accomplished, was to have something real-time using all the effects that you would expect. I don't think it would have much slowdown if we got to planes. So basically the proof of concept was, can you make a decent looking 3D Pac-Man style game where the main goal is picking up spheres, and you could imagine on the ground there's some planes that are reflecting, and on the sides there would be planes affecting and reflecting and such, and it should all work. It shouldn't incur much speed slowdown. So let's just rotate. So this is our constant frames per second, more or less, and this is not even doing any fancy stuff. This is just using QT, and it looks pretty fast. Now even if we set it at a lower threshold, and I kind of like this bar, it's almost like it's sort of like your computer. What can your computer handle? And you get to set it yourself. Like, oh, I can't really go full speed, so I have to kind of go. I can't go full resolution because I can't go at full speed, so I have to lower the resolution so I can play the game, or blah blah blah. You get it. Yeah, so the main idea was like, okay, it should be a game that you can play somehow, and it looks like if this is the resolution, it would go very fast, and probably could get more spheres in there. I did some smart stuff when it comes to the basic the basic coding. A little tricky to describe it all. And it is a little bit tricky to see it, but everything is moving right now. They're all moving towards each other. We can let that play out a bit, because eventually they should kind of clump together. The lights will probably go away, but all of the objects will clump together. That will be the end of the video, because I'm sure I'll think of one or two more things to say. Thank you for watching. Yeah. The single pixels in the background, they kind of remind me of stars, just like enough light to emerge from the darkness. That's kind of cool. I think this could be pretty interesting. As simple as it is, it's obviously pretty interesting. So yeah, here they are. They're coming close together, and you can see all of the reflections and bloody blah. Let's take a big look at that. So yeah, I do not know why it does the flickering, but it may have to do with the multiple moving light sources. It could have to do with some sort of minor error in the ray tracer. Especially with the use of random or jittering or something along those lines. I did my best to make it work as I would expect, but it looks like there is a couple artifacts of this manner. But you know, if it was a video game, I could imagine that that would not be a big concern. You know, you wouldn't see it too much. Definitely, there are some weirdnesses with the when you get up close. Like here, this is perfect. We're right up close to something. It just looks a bit. It just looks a bit weird. I don't know. I should have more good things to say because it's good too. Pros and cons. Let's keep this thing going. I want to see all these spheres hit each other because it proves to the viewer that there is some animation going on besides moving the camera, and that's a big thing because it would be one thing to say it's a game, but all that's happening is the camera's moving. But this shows that other things can change, the size of spheres, the colors, and all that. Although it's not all hooked in, proof of concept more or less serves that we could do another 100 or 1,000 operations per tick, maybe less, but you know, that sort of idea. And if we brought it down to here, obviously, we could have a lot more shit going on. The main classes, I'm just going to go through them. Maybe the marker will appreciate that. We have a camera that's moving around. The camera has a ray, and moving with the arrow keys is basically just moving that ray around. It looks like it zooms out, but that's not on purpose. That makes sense though because of the code. So that's interesting. It spirals out when you rotate. So that's another little error I had, but you know, it's not a big error because the whole point is just to draw the pictures. They look pretty nice. They're kind of in rave mode right now. Yeah, so do not know why it flashes, but if you took a solid picture, it would look good. And I bet if you increase the resolution and depth to whatever you want, and just render it as an image, it would look very nice. I don't see why not. I bet it would look just as capable as any other one, any other ray tracer. Maybe not the best ray tracers for these static images, but certainly it has its own merits. As I said, the colors change, but I dialed it in so that it would be perfect for the high resolution stuff. Yep. Just moving my camera around. I think I could have changed the speed that you zoom in and out, but I just made it so it would be easy to use and not slow, because it would be annoying on someone's computer if it was just too dang slow and stuff. Look at that. So that looks pretty good to me. Definitely rambling because I want to get everything out there. And a lot of help from online sources to just learn the algorithms, more or less, using some fancy techniques in C++. Some techniques I didn't get to, so for instance, I designed the ray tracer in such a way that the code wouldn't have to change much when adding new geometric objects, no matter what they would be. So a sphere, or a plane, or an infinite plane, or a triangle, all of these things would be subclasses to a interface known as geometry.h, and that interface defines two functions. Right now, I guess, you know, and the functions are intersection results queries that gives you information about an intersection collision, and that's used for the ray tracer. And it also, the geometry parent interface also has a function to get the normal. So just a bit of information that should be standard for any kind of collision, no matter what shape it is. That's basically what the principle was. It didn't go very far because the reason I didn't put planes and infinite planes in is my code just got like 40 lines of stuff. Assignments due pretty soon. I had to basically stop before it was easy to make errors. More or less, boopity boop. Boy. Yep. So that's the long and short of it. There's also some uses of inline functions to hopefully speed things up. More or less, the code is written in such a way that it's not very safe code, but it's fast code and it makes its own decisions. It doesn't really rely on exactly what a workbook might say. For instance, this is a good example. There is a multi-sampling effect that is going on, and it's small. There's 3 rays that come out for every pixel, and those rays are jittered a little bit. So of those 3 rays, you add them up and then you get the average. But only one of those rays has full depth, the other ones have less depth. I don't know if that's causing the jittering or anything, but I don't think so. I think that it was a good move to make multi-sampling with different amounts of depth. It just reduces the problem load a lot. Could be making some errors, but like I said, this was written in the style of a game developer to create something that runs real time and in 60 frames per second. And this looks very much like 60 frames per second. So I really did hit my goal. It honestly made getting some of the other points more difficult. Like, for example, modeling and... No, not modeling. The threads part. There's not much I could do to make this threaded without really changing a lot of it. But as you can see, it's running quite fast without threading, so that kind of makes me excited for its potential, or at least its use as a demo to serve a purpose. Thank you for watching. If you have any questions, non-assignment marker persons, go ahead and ask me. It's not very impressive, it's just an assignment. Thank you. Goodbye.